Happy Monday, Limerick Bio students. Hopefully everyone had a restful weekend. You're looking forward to the short week coming up. We've been told not to assign anything between Thursday and Monday for the holiday weekend, and we've also moved into 2 days of work a week policy, so I'm assuming you're probably getting loaded up with a bunch of stuff right about now, considering we only have 3 days this week. In any case, we're in the home stretch of ecology finally, with the last 2 parts to talk about. So we have a few more clips mixed in here to watch. I think I'm going to probably put up both of my videos for this week at the same time Monday, so you have them and can get them out of the way early if you want to. But in any case, for those of you actually doing notes at home still, we're going to finish the last part of Human Impact Part 2 today from last week before we wrap up the chapter in the next video. So we only got through most of that one lesson last week. I wanted to spread out a little bit more so we had time for a lot of different cartoons and things. So we're going to jump back into that for a little bit now and then move into some new things. So we're on still Human Impact Part 2 in your notes, and we're going to pick it up right here where we left off. For now, we're going to get into some things you probably, I'm assuming, have seen in earth science and probably middle school before that. And it's good that you hopefully have some kind of knowledge base in this already, some kind of experience with it, because it typically is a significant part of the Regents. And as far as we know, you still will have a test at this point. We'll see if that changes at any point going forward. But for now, we'll get back into these things. So anything that we make use of can be considered a resource. And these are divided up into renewable and non-renewable resources. So renewable resources are things that can be readily replaced and continuously made use of. So like sunlight, wind, geothermal energy, that's when you get heat from the earth, or hydroelectric power, which is when water turns a wheel. So like what might happen in a dam or a mill. And these resources don't run out. There are also non-renewable resources. And these are things that there are not unlimited supplies of, so things that will run out. So this is stuff like fossil fuels. So that's coal, oil, natural gas. Nuclear energy sources also count as non-renewable resources since they get broken down, decay during use. They run out as we use them up. But an important distinction to make here is that I said renewable resources were readily replaced and don't run out. We can get more fossil fuels. So fossil fuels are non-renewable resources, but we typically technically can replace them. It's just that it takes millions of years and depends on different environmental conditions to do that. So it's not that we can't ever get more fossil fuels. It's just for us, it's unrealistic because it's going to take so long, we're never going to see it happen. So yeah, we could replace oil, but for all intents and purposes, once we use up the non-renewable resources that are here on the earth right now, they're gone. We're never going to have a chance to get them back. Whereas sunlight is always going to be shining, wind's always going to be blowing. So just want to make that clear because it's really easy to get confused by. We could technically get these non-renewable stuff back. It's just really not a realistic option for us at this time. And one last thing about this, I'm sorry it has to be mentioned, but wind turbines do not kill birds to any appreciable degree. I know that's been a thing out in the world that people have said at times. The numbers of birds killed by these things are minuscule compared to bird deaths caused by power lines and people. And wind power definitely does not cause cancer. I feel dumber for having to say that out loud because that's an insane thing to have to put into words. But there has been, unfortunately, as I said, some confusion in recent times, so here we are. The wind does not make you sick. Hopefully you know that because you have working brains. And moving on. Besides the fact that non-renewable resources, by definition, will run out at some point, they're also the ones that hurt the environment, like a lot. We've thankfully seen a much bigger push towards solar and wind and other renewables in the last few years, though unfortunately the US is still way behind the rest of the world on this front for some reason. One alternative fuel source that you may have heard of at some point is biofuels, and as the name would imply, these are energy sources that come from living things, often corn or algae. So this works because the fossil fuels that we usually burn are organic compounds. They have carbons and hydrogens, and so are the foods that we eat, as we saw in the very beginning of the year. So we can take organic tissue, and under the right conditions, it can be converted into an alcohol-like energy source for specially designed engines. This is not a widespread use thing, but it is something that is being worked on. It has been for a couple years now. However, while this is technically a renewable type of resource, because we can keep taking different food products and trying to make this stuff, biofuels still release carbon dioxide when burned. So it's not a clean energy source like solar or wind power would be. So when I was in college, one of my roommates had a friend who had this really weird car, and it had some kind of modified engine that used regular gasoline, but also had a separate intake part that let it run on biofuels. So she made a deal with her local McDonald's, and every week or so, she would go pick up their used oil from the fryer to pour into her car's biofuel tank. It cut down on the money she spent on gas, but it also made her car always smell like French fries, which I imagine got really old really quickly. Okay, that's the last part of lesson 2. or part 2 rather. So we're going to move it on now to the last part of Human Impact Part 3. And I'm actually going to split this lesson up also into 2 parts because I think it just fits better, it works better, it makes more sense this way. And again, it'll let us fit in a couple of cartoon videos also. Besides not having a huge file to try to record and save, it'll also just make more sense time-wise, so you're not having like a 15-20 minute video to watch. We definitely want to be able to fit in those cartoons where we can. So right here, you get a question on your screen. Explain 3 ways in which human beings have negatively impacted our environment. Just think back to stuff we've done the last week or so. Give yourself a couple quick notes to refresh your memory about what we've seen, and we'll move on and try to finish this up as quick as we can. For this part today, we're going to look at the greenhouse effect, which we have a few questions about here on the screen already. The greenhouse effect is something that you may have heard about in a negative way because of problems related to it for the last few decades, but it is a normal thing that's supposed to happen where everything is working properly. The greenhouse effect is when sunlight and especially heat energy enter the Earth's atmosphere, hit the planet, and then bounce off. Some heat energy is absorbed by the planet, but a lot of it is reflected and goes back into space. As you can see on the left picture, a small amount of the energy that is reflected off the planet is trapped by gases in the Earth's atmosphere and can't escape. This helps to keep the Earth warm, and it's why it doesn't get freezing cold every night as soon as the sun goes down. So again, this process is a good thing and important for life survival. So we call it the greenhouse effect because it's like a greenhouse you might see in somebody's garden. Light goes in, gets sort of trapped inside. It's a very balmy environment. It's a very warm and humid environment in these greenhouses, so plants grow better. However, it's gone too far for our planet due to a buildup of man-made gases. So greenhouse gases are things like carbon dioxide and methane that help to trap the heat. And they're normally, it's a typical thing, but people have greatly increased their amounts in the atmosphere, so there's a lot more present up in the air than there should be. As a result, the Earth's temperature keeps increasing because more and more heat gets trapped and can't get out. You see a mention of these gases on the left side. They're called CFCs, which are chlorofluorocarbons, which are carbon compounds that contain chlorine and fluorine, and used to be found in aerosol sprays in refrigerators or freezers. Another issue with this is that because of the deforestation issue we saw previously, the CO2 can't be cleared out of the air as easily. So there's not as many trees as there used to be, so it takes a lot longer for plants to get the extra carbon dioxide out of the air along with methane. And in the meantime, more and more of these carbon dioxide and methane gases are constantly being added and released out into the atmosphere again. As for a solution to this problem, we'll see that in a minute. Just in case anyone thinks this is some recent idea with any kind of bias involved, none other than telephone inventor Alexander Graham Bell predicted the greenhouse effect about 70 years before people finally started paying attention to it. And there's his name. Nice way I animated that first, but oh well. Going hand in hand with the greenhouse effect is the issue of ozone depletion. And this is another thing you may have heard about at some point, maybe not. The ozone layer is part of our atmosphere. So ozone is a form of oxygen. The oxygen we breathe in is 2 oxygen atoms attached to each other, and ozone is 3 oxygen atoms attached to each other. So if I draw this right here, normally we breathe in, let's do it right at the top here. So we usually breathe in 2 little oxygen atoms attached like that. That's O2. And ozone is just 3 oxygen atoms like that linked together. And that we'd call O3. So it's a similar substance to what we breathe. It's just a different form of this element, oxygen. So 3 atoms of it as compared to 2 atoms of it. So part of our atmosphere around the planet is this layer of the gas ozone, and it helps prevent bad radiation from getting to the planet. So while greenhouse gases stop some of the sun's rays from escaping once they're here, the ozone layer is supposed to stop more dangerous stuff from even getting to us in the first place. The problem is that some of those same CFC chemicals from aerosols and refrigerators that we saw before tend to break down the ozone gas around the planet, forming holes in the ozone layer that lets dangerous radiation get in. So normally there'd be this whole little kind of protective bubble around the planet. And what happens when these gases come along is they go instead and start to, oh, now it erased everything. So if I had all those gases, let's try to put those back. If I had that nice little protective layer right here, it won't let me use an eraser properly, so let's pretend the red I'm going to use is an eraser instead. It would start to make holes in the layer like this. So now you have all these little chunks taken out of this layer, and what happens now is all the nice energy from the sun that we want to get in starts to sneak through, but all this bad stuff gets into, and all extra radiation gets to the planet, and we don't really want that because that's really, really bad. It'd be like just pouring radiation on us, and that's typically a bad thing. So this led to a big increase in cases of skin cancer in the 70s and 80s, as people were exposed to really unhealthy levels of UV rays. So humans aren't the only ones affected by this, and it led to a loss of biodiversity, as we were seeing a while ago. And, last week we saw pretty much everything bad that happened led to loss of biodiversity. It killed plants, it killed animals, not just people. Thankfully, a lot of intelligent people all over the world listened to the doctors and the scientific community who pointed out what a problem this was. And in 1987, the world's governments signed the Montreal Protocols that agreed to stop CFC use so it wouldn't be a problem anymore. Imagine that. Scientists warned of a catastrophic problem and people actually listened. The world economy survived. We still have aerosols and refrigerators, just different forms of them, because people work to find an answer to the problem instead of ignoring it. Funny how that works. So it's Monday morning. I was just woken up by an email from YouTube saying that this video was taken down as originally recorded on whatever day over the weekend because someone who had a copyright ownership for a little video clip I used objected to it and doesn't want us to use it anymore, which I have done how many of these things. I gave you the Captain Planet clip. I've given you a couple things. No one has ever had any issue with this. I put right in the description. I do not make any copyright claims. This is all for education, but that apparently was not good enough for them. So I now have to record this stupid little slide and give you that disclaimer myself. And hopefully no one has tried to watch this and not been able to in the meantime. So I will re-record this video because that's the kind of thing I have time to do nowadays and put it back up and hopefully no issues going forward. Couldn't have said it better, Frank, you timeless treasure. The good news is the Montreal Protocols have worked. It's taken over 30 years, but we're seeing real change, and this report from NASA in the fall shows that the hole in the ozone layer is the smallest it's been in a long time. When people think reasonably and accept challenges instead of refusing to believe the evidence all around them, we're able to get good things done. We're going to stop there and have just one more thing to do in this chapter. Once again, I'm going to put up both videos together on Monday, but list them as Monday, Tuesday on OneNote, so you'll see them in two different places. Make sure you do both things whenever you get to it. I'm also going to do another extra help meeting on Microsoft Teams Tuesday at 12 noon for anyone having any issues with this material. For now, go finish the form, ask any questions, and I'll talk to you soon.